Hi, I'm Pat Kelly. Okay, and in this problem, we're asked to find the particular solution to this differential equation that they've given us, and they've also given us the general solution. This is where we're using a model that we've already seen before. And our task is really just to find the particular solution that would correspond to these initial conditions. We have the two different initial conditions. So we've been down this road before where we're using the information from the initial conditions, plugging into our general solution, and trying to find values for these parameters C and K. Let me give you a heads up. You're going to want to have a calculator handy for this one. There's some computation that we'll have to do. Okay, but the basic mechanics are the same as we've been doing. I'm going to start with that general solution of y equals 200 times e raised to, be careful, it's raised to the minus c times e raised to the minus kt power. So you have that power within a power. But the basic mechanics that I mentioned is now we just take our y equals 100, our t equals 0, plug those in to this general solution, and we'll find one of those parameters. So my y is 100 equals 200 e minus c e raised to the minus k times the specific value of t of 0. Now we'll simplify. 100 equals 200 e raised to the minus c times e raised to the 0 power. We've seen 100 times. That's 1. So I just have that minus c in my exponent now. I'm trying to solve for that c. I'll divide over the 200, and I'll get 1/2 equals e raised to the minus c. And we've solved equations like that before as well. The minus natural log of 1/2 is going to equal c. So I'd grab a calculator for that one. We find the natural log of 0.5. I'm getting a negative 0.693. If you heard me say negative, there's a minus sign in front as well, so we'll end up with c being a positive 0.693. Keep the calculator handy. Now we're going to go to our second initial condition and use its information to find that specific value for k, the other parameter that we're missing. So I'll begin back with my general solution, y equals 200 e raised to the negative c, which I now know is 0.693, and then the rest of it is multiplied by e raised to the minus kt power. Okay, so that's our general solution with the one value known we figured out, and I'm going to use this specific y equals 150 and t equals 2 now into that. 150 equals 200 e negative 0.693 e raised to the minus kt. T is 2. Let's say minus 2k. Now this equation we can solve for k. A little bit of algebra and definitely a bit of computation. So let's go ahead and do that. Bring the 200 over. I'll get 0.75. That was just a division of 200. E raised to that negative 0.693. E raised to the negative 2k power. Okay. Now really solving for k here, I know it's involved, but it's e raised to a power. Focus first on that. I mean, don't focus on the complexity of the power. E to that power, I'm just going to do logarithms again. So natural log of each side, and I'm bringing that minus sign with it. That's going to equal whatever was up there in the exponent, 0.693 e raised to the negative 2k. So we've done those kinds of problems where we're solving for something that's in an exponent. That's where we're using our logarithms. And the complexity of this one is just that what's in that exponent is involved, but it just comes right back out like it usually does from the exponent. Now I'm going to grab a calculator for this negative natural log of 0.75. Natural log 0.75 is a negative 0.288. You might have heard me say negative again, but it's negative, negative, so that's positive. This equals 0.693 e to the negative 2k. Trying to solve for k. It's in an exponent still, so we'll use our logarithms again. Before I do that, I'll divide over that 0.693 to make it cleaner. 0.288 divided 0.693 e raised to the negative 2k. Almost there. I'm going to slip up here just for some more room. I'll do that division on my calculator. 0.288 divided by 0.693, 0.416 equals e raised to the minus 2k power. Now we'll do those logarithms, and here are my minus natural log 0.416 will equal 2k. Go to the calculator, evaluate this natural log. I'm doing a natural log 0.416. That is a negative 0.877. One more time, you heard me say negative. There's a minus in front, so it's a positive 0.877 equaling 2k. Finally, just a division by 2 is going to give me my k. 0.877 divided by 2. 0.439. So it took some doing, but we have a value for k now. Let's put it together, wrap this problem up. Put it together by grabbing that value of c, that value of k, and going into our general solution. Let me grab this space and do that. 200 e raised to the minus c, 0.693. Multiplied by e raised to the minus k. K is my 0.439, and then the t that's there. And so that gives us y as a function of t as we wanted in terms of a particular solution to this differential equation. That was some good algebra exercise, I think. And that would be a wrap on that. Thanks. Hope that helped.